Okay, so I make that 9 a.m, so we'll make a start. First of all, thanks for joining us today. This is the second session in our mini series of Raytec Live Drop-in Sessions. Some of you might have joined us a couple of weeks ago for the EXE versus EXD certification session. Today we'll be looking at source lumens versus delivered lumens. And then we have the final session, so in 2 weeks' time, which will look at well glass versus bay lighting. But yes, for today, we will be looking at source lumens versus delivered lumens. There are two of us on the webinar today. My name is Jasmine Adams, and I'm the Marketing Executive at Raytec. And I'm here with Jonathan Somerset, who I'll pass you over to shortly to introduce himself. Just a couple of housekeeping rules to run through first. The presentation should last around 20 minutes. And following that, we will give you the opportunity for any questions that you might have. If you do have anything you would like to ask, please just submit your questions into the question tab of the control panel, and we'll come to those at the end. Other than that, I think we're ready to get started, so I'll pass you over to Jonathan.
Okay, thanks Jasmine, and hello, and thank you for taking the time to join us for this second in this series of Raytec Live Drop-in Sessions. My name is Jonathan Somerset, and I am the Product Manager for Raytec's Hazardous Area Division. The subject of today's webinar is source lumens versus delivered lumens. Now, this can sometimes be a contentious issue within the industry, so we'll try to explore the subject in a little more detail and aim to provide a bit of clarity by the end of today's session. So let's take a look at some of the issues we'll be covering in today's session. So first up is source lumens versus delivered lumens. What exactly is the difference between these two things? And what factors affect these different quantities? After that, we'll look at consistency across manufacturers. Are all data sheets showing the same information? We'll then look at the importance of lighting design in ensuring you meet your target illuminance levels. And finally, the Raytec approach. So there are lots of factors to consider when specifying a hazardous area product. And lumen output is right up there as one of the most important considerations. But are all lumen outputs comparable? In this session, we will explore the difference between source lumens and delivered lumens. So in our industry, we talk a lot about lumens every single day, but I'll take this opportunity to go back to basics and look at what exactly is a lumen. Fundamentally, a lumen is the SI-derived unit for luminous flux. It's how we measure how much light is being emitted from a light source. If you break it down further, it is equal to 1 candela steradian. Now, if you remember back to your school days, you'll know, or maybe you'll remember, that steradian is a unit of solid angle, and there are 4 pi steradians in a complete sphere. So a standard candle emitting 1 candela uniformly in all directions will be emitting 1 times 4 pi lumens, which is around 12.5 lumens. But crucially, luminous flux is correlated to the spectral response curve of the human eye. The same amount of radiant flux will appear brighter to the human eye at 555 nanometers, and hence worth around 20 times the lumens as that same radiant flux at the blue end of the spectrum or the red end of the spectrum. So this is why, for those of you that remember those old old-fashioned low-pressure sodium lamps, they had excellent lumens per watt figures, as they only emitted light at the most sensitive part of the spectrum. So let's look at how we're defining source lumens and delivered lumens. Source lumens are the total amount of light that a luminaire emits at source level. Now, in most applications these days, that means that that's the amount of light that the LEDs themselves emit. Whereas delivered lumens is the total amount of light that the luminaire emits as a system. This includes any losses inherent within that system, whereas source lumens does not. Now, source lumens gives you a great headline figure for your datasheet, but delivered lumens are the most accurate way to measure how a luminaire will actually perform in a real-life application. So what affects source lumens? If you're designing a luminaire on a blank sheet of paper, you may start with LED selection. So firstly, LED manufacturer. They all tend to offer pretty similar types of chips, but their performance figures and data will be subtly different. You may already have a preferred LED manufacturer, in which case you would look at their range of LED light sources and select the type of LED you want. Mid-power LEDs tend to offer excellent efficacies and value, but sometimes at the expense of longevity. High-power chips are very robust, and they may offer better performance with secondary optics, such as lenses. And chip-on-board offer very dense lumen packages, so they give you a great deal of punch in a very small form factor. This also means that thermal design is even more important for chip-on-board luminaires. So once you've decided what sort of LED you want to use, you'll now need to look at how many you actually need in your system to hit your desired lumen package. Next up, LED bin. Now, LED manufacturing is not as precise as you might think. LEDs are tested as they come off the production process and binned according to their performance. One of these categories is color temperature. A lot of LEDs use deep blue light source and then convert that light to white using a phosphor layer. So if you're looking at an LED chip, the phosphor layer is the distinctive yellow square that you see in the center of a lot of LEDs. The warmer the color temperature you select, the more work the phosphor has to do, and generally the lower the lumen output. Similarly, for color rendering index, to get a high CRI, you must use denser phosphor layer, and generally this reduces the lumen output. LEDs are also binned by luminous flux. Within each color temperature category, you may get 4 or 5 different flux bins. The top bins have the highest performance figures and hence the highest lumens per watt, but usually these are at the expense of the lowest yield, and hence these top flux bins demand the highest prices. Some manufacturers also bin by forward voltage. The lower the forward voltage per LED means you need less volts for the same drive current, and hence better source lumens per watt. Which brings us on to drive current. Generally, the higher the drive current of the LEDs, the more light you get from your light source. However, this is not entirely a linear relationship. Due to internal losses within the LED, you'll see on the sample graph that simply doubling the drive current from 350 milliamps up to 700 milliamps does not quite give you double the luminous flux. You actually only get 80% more light for doubling the forward current. Also beware that you may be tempted to drive the LEDs at their maximum rated current to give you the most bang for your buck, but this can dramatically reduce the lifetime of the fitting. Also, generally speaking, you need to run your LEDs from a PSU or LED driver, which will have a defined output voltage and drive current range. This limits your options on how to drive your LEDs. This is also true of LED PCB schematic. You'll need to match the LED string lengths to the forward voltage and drive current range of your PSU or driver, meaning you may not be able to run the LEDs at their optimum performance window. So that's source lumens, and now we'll look at what affects delivered lumens. So one of the key factors in any LED luminaire is good thermal design. This is not only true to maximize the lifetime of the LED, because as we all know, the cool running LEDs last longer than hot ones, but it also affects the performance. This graph shows how a particular LED performance is related to its junction temperature. So this particular LED was binned at 85 degrees C. So reducing the junction temperature can give you up to 10% more light, and conversely, increasing the junction temperature beyond 85 degrees can severely reduce your performance. But by far and away, the biggest effect on delivered lumens is optical design. Once your light leaves the LED, it then usually needs to pass through at least one more layer of material, whether that's the outer glass of the luminaire or a plastic diffuser. The better the quality of the materials used, the higher the transmission and the more delivered lumens you get. So you might think that the ideal luminaire would have no secondary optics, and this keeps the transmission to a maximum. Now this can be true to a point, but light is only useful if it is directed to the task where it is needed. This is where a good secondary optic comes in. Secondary optics also have the added benefit of reducing total internal reflection within the luminaire and reduces other light loss and glare due to emission at high angles. So in our industry, there can be a degree of uncertainty as to which of these figures you are being given. As we've seen, performance can be measured differently and will give dramatically different results once installed. Even figures on datasheets can be misleading, so if in doubt, ask. Let's look at these two examples. The design on the left assumes a fitting with a quoted lumen package of 25,000 lumens, but unknown to you, these are source lumens, and once the losses in the system are taken into account, your installation is falling short of the required lux levels. The design on the right assumes a fitting with a quoted lumen package of 25,000 lumens, same as the first, but this time these are delivered lumens. You get the light that you expect, and you can see in the picture that you get a dramatically higher on-scene illuminance as a result. We'll look at that same diagram in pseudo colors, and this shows a distinct difference in on-scene illuminance between these two fittings, which appear the same on paper. So this brings us nicely on to the importance of good lighting design. Lighting design provides clarity on a luminaire's performance and makes sure we're comparing apples with apples. To be used in lighting design software, a luminaire's performance is measured and turned into a photometric file, usually by an independent test lab. They will measure the intensity distribution and the delivered lumens from the luminaire, which the lighting design software can then use to simulate the on-scene illuminance. You also get a visual representation of the final solution, which sometimes can show up any shortcomings in the project, which can then be addressed early on, which is better doing that than trying to repair a fitting after it's been installed. So what is the Raytec approach? At Raytec, our lumen output figures quoted are always delivered lumens. What you see is what you get. We often use secondary optics to direct light exactly where required, maximizing efficiency and keeping spill light and pollution to a minimum. Photometric files for all our products are available to download from our website and used in your own lighting designs. Or alternatively, you can call on our expert, award-winning, and most importantly free lighting design service. Good lighting design can really save you a lot of energy, installation time, and ultimately money on your project. So thank you for listening. Hope this has been informative. Myself and Jasmine will now turn on our webcams and answer any questions that you may have for us.
Thanks, Jonathan. So yeah, we'll turn on our webcams now. So if you don't know who we are, you've never met us, you'll be able to put a face to the name. Here we go. So if you do have any questions, please just submit them and we'll start answering those as soon as we can. We have had one come through straight away there, so I'll pass this over to you, Jonathan. Do you have any thoughts on why some manufacturers still quote a source lumen value on LED luminaires? Is this more due to the historical understanding of relative photometry? And that's from Ken.
Yeah, there can be the historical context to that. So in the old days, we used to do relative photometric measurements where we would take a lamp, whether that be a fluorescent lamp or a sodium lamp or a low pressure sodium lamp, and we would measure the output of the luminaire compared to that reference lamp. So source lumens were important at the time, but you always applied a light output ratio to your product. As we know, with LED technology, relative photometry doesn't really work. You have to use absolute photometry. Now, why some manufacturers still quote source lumens could potentially be, maybe not intentionally to mislead the customer, but source lumens do give you a nice headline figure on your data sheet. So if you see something like 180 or 200 lumens per watt, you can be pretty sure it's probably source lumens and not taking into account all the losses in the system. So I think it could be related to historical measurement techniques, but also trying to get the best headline figure on your data sheet.
Thanks, Jonathan. There's another one come through here. Can you comment on the 6000K CCT quoted by Raytec?
Yep, so 6000 Kelvin. If you look at one of our earlier slides, you can see the spectral response curve of the human eye, and that's photopic spectral response. There's also another ratio where the human eye response curve changes slightly at low light levels down to scotopic range, and then the difference between scotopic and photopic light curve gives you your SP ratio. Now, high color temperature light appears brighter at low levels of light, so it's particularly good for outdoor lighting. So Raytec's approach is to generally offer 6000 Kelvin, but we also offer 5000 and 4000 Kelvin luminaires for any application you have in mind.
Thank you. And we've got a question from Asif. Any special consideration while choosing for EX use?
No special consideration for EX use, no. We're still providing luminaires that are meant to be used with humans, so we're still trying to provide visible light that humans can do the task that's necessary. So in this regard, all lights are pretty equal. Industrial applications, hazardous applications, all require the same sort of photopic standards.
See if we've got any more. A question from Logan. How can I tell whether the manufacturer has published source or delivered lumens?
Well, if in doubt, I think the best advice is to just ask them. So a lot of manufacturers are usually quite keen to talk to their customers. So if in doubt, do ask the question. Also ask for photometric files. So as we've seen, photometric files usually are produced by an independent test lab, and therefore you get measured results which can be compared against other manufacturers. Also, if you're looking at a data sheet and something looks out of place, whether a lumen per watt figure is much higher than the rest of the competition you're looking at, then sometimes these things can be too good to be true. So, and you might want to ask the question about that as well. But if in doubt, ask the question and request photometric files.
Thanks. We've got one more here from Michael. How much light is typically lost due to a lens over the LEDs?
So each layer of transmission, generally you lose around about 10% of your light. So although a bit of glass or plastic may seem transparent, usually these actually absorb around 10% of the light that passes through them. So if you have an LED light source that passes through a secondary lens and then through an outer plastic cover, then you usually lose about 10% in each case, which means that delivered lumens tends to be about 80% of source lumens.
We have had another one come through there from David. Which software does Raytec use for their design?
In terms of lighting design, we use 3 of the proprietary lighting design softwares that are out there. We can do lighting designs in Relux, in Dialux. If you're looking for street lighting designs, we also use Lighting Reality. So all the major lighting design softwares on the market. If you have a particular preference, then Raytec can do your design in whatever software you have preference for.
Great, thanks very much, Jonathan. So that's all of the questions we've had answered. We'll hang around for a little longer just in case any more do come through, but we'll turn our cameras off. Just to say thank you for joining us today. As I said at the start, this was the 2nd session of our 3-part series of the Raytec Live Drop-in Sessions. So the 3rd and final one will take place in 2 weeks' time. So hopefully we'll see you there, but thanks again. Thanks for joining us today.
Yes, thanks for joining us.